In this video, I would like to show you how to use Ansible to do system automation on FreeBSD systems. Okay, let's have a look. In order to use Ansible to install, for example, software on a FreeBSD machine, we need to have access to that machine. In order to have access to that machine, typically we need to prepare the machine for this access. One of the ways that we can do is to pre-install, for example, doas and enable users belonging to the wheel group to execute the doas command. This way, when you run Ansible on that machine, Ansible can become root and execute privileged actions. Another way that you can do, which is similar to what Cloudinit does, is that you can install an SSH key in your target machine and then use this SSH key with Ansible to have access to the machine. In this video, I would like to show you how to do Ansible on a bare bones machine. You just installed it now, fresh from the DVD. The only requirement that you have to do what I'm about to show you is that you need to have created one user which is on the wheel group, and you need to have SSH enabled. The main problem that we have with running Ansible on this kind of machine, which neither has doas installed, neither does it have a local SSH key that you can use to log into the machine, is that you cannot really use SU to automate the process, because SU doesn't take a root password from stdin. Let me show you. Here I've prepared my main machine to have the root password, which is root, because I'm going to show the strategy. And therefore, if I do su dash, I can type ROOT and I become root. What happened here is that SU has confirmed whether I'm inputting the password from a TTY or whether this is coming from a standard input. Let's try to do some other things. So we can try to put the password directly with echo. Let's actually do the printf root and do a carriage return and then capture the keyboard, which would be something that we would typically use for automation, and then do an su dash. Here, as you can see, it's asking me for the password, so it didn't really accept root as from the standard input. This breaks down the automation process. This is actually a good security feature, don't get me wrong, but I want to try to circumvent this. And in order to circumvent this, we need to be a little bit clever. But in order to circumvent this, we need to do some little bit of trickery. And the trick is that we need to make SU think that it's running from a terminal, from a TTY. So let's try to exit from here. Sorry, okay. Okay, we have exit now. So for that, what I'm going to do is I'm going to create a program that is going to start SU in a terminal and is going to pipe whatever comes from the standard input into this terminal. Let's do it. So let's do a demo directory, and I'm going to call it password for su.c, and I'm going to write this program shortly, and then I'm going to explain you how does it work. So how does this program work? Let's start from the beginning. The first thing that we do is that we install a sig action, a signal, that goes to the sig act. The sig act points to the signal child signal, which just sets the global variable flag equals to 1. So when the parent receives a signal that the child has died, that no longer exists, then it sets the flag to 1. The next thing is we open a TTY. This is achieved with a POSIX OpenPT, and we get this in the file descriptor. Then we get the file name under the PTS name here with this printf, and here we do a fork. The child is here, this is the code for the child, and for the parent is this one here. So what happens at the child, we close the PTY, we don't need it. We close the FD, and now we open the PTS name here. And now what we do is we duplicate this FD to the standard input, standard error, and standard output. And we do an exec VP, which we call the argument, and notice that next arguments go with the argv1, meaning that any parameter that is added after here is just going to be passed one-to-one to the exec VP. That's it, nothing more for the child. The parent goes on an infinite loop here. In the first it seems like an infinite loop, but the first instructions we see is the if flag. So, and if flag is set, then we basically break from this loop, meaning that the child has sent a signal child. The next thing is we do a select on the standard input and on the file descriptor. This file descriptor is coming from the TTY that we just created. And now here comes the trick that if anything is coming from the file descriptor, we just write it to the standard output. So we read from the PTY and we write it to the standard output. And if anything is coming from 0, from the keyboard, we read it and we write it to the TTY. Okay, if the child has exited, what we do, we read everything that is left in the TTY and we just print it to the console. We want to be nice. And then we just exit. That's it, very simple. So let's compile this, cc-o, and we write like this. Okay, there are some errors. Let's try to fix them. So let's now try to make this run. The first thing that I'm going to do is I'm going to printf the password, which is going to be root. I'm going to add a carriage return, and I'm going to type it into my passu with su -m root and who am I. And as you can see, this is apparently not working. Well, not really. The thing is that the program that I've done is so simple that it's actually pretty stupid, and it's not really synchronizing the start of one process and another one. So be careful if you want to use this in a production system. So I'm just going to do an artificial slip here and then print the password, and let's see if this works. Oh, okay. As you can see, now the password is no longer asked. And I get here, who am I, root, and I can ask the pwd. Yep, it looks like it's running. Or I can even do two commands, so pwd and who am I with another pwd. There we go. Okay, now let's try to make this run on my virtual machine. This machine has just been installed and has absolutely no software, except that it has two users. It has root with password root and the user tg with password tg. Let's try to enter with root or with tg, password tg, and let's do an if config. Okay, so we are at 10.02.15. Let's try to ping the machine. Ping 10.02.15. It doesn't work. The reason it doesn't work is that with VirtualBox, the netted system is not reachable from the host. So let's try to change that. And here in the settings, what I'm going to do is that on the network, I'm actually going to change this to a breached adapter. Let's retry to start the machine. So now let's just enter as root with password root and if config. Now we have the IP address 192.168.2.154 and we should be able to ping this machine now. Let's try ping 192.168.2.154 and we can reach this machine. Now let's try to SSH to the machine, SSH TG at 192.168.2.154. This is the first time I'm connecting to the machine. And now what you see here is that it's asking me for the passphrase for my standard. And now what you're seeing here is that this is asking for the password. And how can we address this? Basically, we need to give SSH the option pub key authentication equals no. Again, this is something that you should not be doing in practice to log in with username and password over SSH, but I'm just doing this for demonstration purposes. So let's try it again. Password TG and we're done. No more asking for the password of my local SSH key. This behavior we can configure under ansible.cfg, ansible.cfg, and this is going to go under the header of SSH connection, and we're going to say SSH args, we require -o pub key authentication equals no. Typically, you should not require this setting. And we're going to create a hosts file. So we need to set the defaults inventory equals to the file. I'm going to call it hosts. To install Ansible, I've not done it before, but you can have, you need the py39 Ansible. This is basically the package that you should be installing. Now let's have a look at our hosts file. Hosts. I'm going to describe that I have the machines which are under demo. It's going to be the 192.168.2.154. Ansible user to connect to the machine is going to be TG, and the Ansible SSH pass is also going to be the TG. So far, so good. Now we need a playbook, a YAML file. Since we have no Python and really no software installed, we need to do a couple of tricks in the playbook that I'm going to show. So the thing is, we have to tell that this is going to be the host for the demo. And here, important, gather facts is going to be false. Then tasks, we're going to describe the first task. I'm going to give it a name, that connectivity, and I'm going to do the task being ping. Okay, and Ansible playbook. On the playbook, we can try the first time to debug if anything goes wrong, -vvvv. Let's go and see. Lots of things are happening. And we see that there is an OK. Ping pong. So we have connection. In case that we would have some problems, the VVV would help. We don't really need this now because we got OK. So our first playbook has already worked properly. Now, what I'm going to do is I'm going to bootstrap the system for Ansible to be able to work properly later on. So the first thing that I'm going to do is I'm going to remove the connectivity and I'm going to say bootstrap doas. So let's go back to the machine. Here, doas is not installed, as you can see. Okay, then let's make sure that this is installed. What I'm going to do is I'm going to execute a shell script locally in the machine, And for the time being, what I'm going to do is touch /tmp/tg.txt. Let's go back to the machine. ls/tmp. There is no tg file, but now let's run the playbook. It's okay. So, and now we have one file there that is called tg. But who does this file belong to? It belongs to the user tg. Okay, the user tg is in the wheel group, as you can see here, because the group for this file belongs to the wheel. But we cannot use the trick with su. It's the only program currently installed that enables us to become root. Therefore, we need to place the file the C file that we just created, we need to put it there. One way that we can do this is in the shell, we can do an echo and we do a look up on a file that we're going to say the passu.c. That's our local file. And we need to pipe this into the Ansible built-in B64 encode. You're going to see in soon why do we need to do this. So we are executing echo and we're going to put this into /tmp/passu.c. Let's run this. Let's go to the machine. We have this passu, and what is this file there? Cat tmp _passu. And as you can see, this is base64 encoded. Why did I do this? Because very simple, you might have carriage returns, which you do have, which could break the echo command. So if you encode base64, this command is guaranteed to work properly. If we do a cat, so in this machine, cat pipe base64 decode, you can see that we can recover the original file. And that is what we're going to do next. So we're going to do a cat /tmp. This is why I gave it an underscore. Passu pipe base64 decode into tmp passu.c, and just for it we're going to remove tmp underscore passu.c. Let's run the command again. Looks fine. And under tmp, what we observe, we have the file there. So cat tmp pass. If I know how to type, it will help. And now the file is properly there. Why did I go through all the trouble? Because this Clang compiler comes pre-installed with the machine. So cc is there. Okay, now we can just compile the file. Look that in the tmp, this file, the .c, also belongs to the user tg, so it doesn't belong to root. But we've just seen in the local machine that we can use this file in order to do some trickery with su. Then, let's say compile tmp passu tmp passu.c. And what I'm going to do now, no, let's first run the playbook just to see. I like to do things in slow steps. And now we have a file there which is compiled and I can run this. So let's run as a normal user /tmp passu ls, it's running ls-l. Okay, so this is now working properly. I have the file compiled locally. And what can I do? Now I can install do as. How can I do that? We just saw the trick with sleep, and we inject the root password. This should then come through environment variables. You should not put too hard code credentials in the file, but again, this is for demonstration purposes. Pipe tmp passu, and now we need to give a full path, user bin su m root, and the command. I'm going to leave this one here for the time being because I'm going to need this a couple of times. pkg install -y doas. Now this command here should, after compiling the passu, it should run su, type in the password over standard input, call pkg install with the doas. Let's cross our fingers. Let's say here demo has been logged in as root, and here what we see pkg is running. Looks like good. Okay, let's just wait a little bit. Okay, it basically said that it's unreachable. Let's try again. Sometimes this happens. The program I wrote is a little bit finicky. Okay, let's try again. Okay, this time it has basically worked, changed. Let's go to the machine and see doas. Look at this, it's existing now, it's there. But the user tg cannot do a doas. So doas doas sh, doas is not enabled. We need to create this file. Let's do it. So one way to do it is to do an echo. What we need, we need permit, we need the rule permit. Anyone, so without pass, anyone with the wheel root, anyone in the wheel group should be able to do it. And we are going to do a doas.conf. So this is the, we create a file, but this file belongs to tg, so we need a couple of things. We need to do the change owner, change mod, and to move the file. So we need 3 commands. So here as root, what we're going to do is we're going to change mod to 644 tmp doas.conf. Okay, let's make it a little bit smaller. We need to change own root wheel tmp doas conf. Okay, still need to make it smaller, sorry for that. I hope you can see this well. And I'm going to move tmp doas.conf to user local etc doas.conf. Last but not the least, I'm just going to do a little bit of house cleaning and do an rm/tmp/passu.c. I don't want to see this there. We need to remove also the executable itself, so we don't forget that. Let's try to run again this. Since it's already installed doas, it should be a little bit faster. Let's do it. Looks good. And let's go back to the machine. You can see that su has been executed a couple of times. And now doas sh. Lo and behold, who am I? Now it's working. This is automation. Exit. Okay. Now, since we have the doas command, what I'm going to do is I'm going to try to create a file similar to what I've done before. So I'm going to actually create another book, which I'm going to say the test.yaml, edit test.yaml, and in my test.yaml I'm going to do something different. What I'm going to do here is I'm going to say this time I want to gather facts, true, and I'm going to do a become Now I can do become, yes, and the become method is a doas method. Now this is existing and it's installed. And who do I want to become? Become user root. So test doas method. And in my shell, I'm going to then say attach tmp hello.txt. Let's try to run the playbook for the test YAML. Okay, didn't work very well. Let's try another time. I don't know why did it fail. Actually, in my experiments, this never happened before, so I'm actually a little bit surprised. But as you can see, this is logging in well properly to the machine. And now ls in tmp, and now we have an hello file which has been created by root. So now we are really root in this machine. Okay, this looks good. So we can do now automation pkg, then install -y mc. Now let's run the test. Testing. And Midnight Commander, there we go. Awesome. Thank you for watching. If you have any questions or comments, use the space down below. Otherwise, I wish you have a nice day and see you next time. Bye bye.